Hey there, Precalc. It's Mr. Troll from the comfort of his home at his dining room table, here to give you guys a little bit of a video lecture for this first section you've got to do in Canvas called Vectors in the Plane. It's module 6.03. So it turns out that we aren't able to get access to the online book that Canvas uses. So when you click through the lesson, there's a list of practice problems to do from some online textbook. We don't have a code for you to get into that. But what I do have is a chart that will tell you which chapters from your textbook, this textbook, okay, this guy, I have a chart that tells me which chapter and will tell you which chapters correspond. So as you can see here, this module 6.03 vectors in the plane, if you flip in your textbook to section 8-2, it's the same section, okay? So anyway, I have assigned some problems, and you'll see them if you look at the modules. You'll see it says module 6.03 vectors in the plane practice problems. I have looked in your textbook and found practice problems that will help you prepare for the quiz on this section. So if you want practice on this stuff, look at those practice problems. You'll also see there's a link there to the worked out solution sheet that I generated, and I uploaded it there. So everything you should need is there. And of course, if you need my help, you can log into Zoom at the office hours or ask me on Remind. Hopefully you all know how to get in touch with me on Remind. Anyway, let's get down to business here. 6.03 vectors in the plane. From this section of the textbook. We'll just cover a few things and then I'll upload the next example in another video. What is a vector? Well, I have a vector right here. A vector is really, it's just a two-dimensional arrow in space on our good old Cartesian plane, our XY plane, that has a direction and a magnitude. Now, if you're in physics, you're familiar. Vectors are used to represent a velocity, a particle moving in space with a certain velocity, or maybe a particle moving in space exerting a certain force in a direction or momentum. There's anything that has a direction and some sort of magnitude can be represented as a vector. So like a ball or a hockey puck on ice, or anything at all that is moving in a direction with either a force or a speed or something of that nature is represented as a vector. So these are very handy in physics and in other applications as well. So here I've got a vector. It has a starting point, A. It has an ending point, B. And I've written the coordinates of those points. Okay, so what is this vector's name? Well, we call it this, AB, with this little arrow above it. Now, in geometry, this is how we denoted array. Okay, now notice I could not write it as BA. That would be a different vector. That'd be the vector that started at B and goes to A. This is the name of the vector AB. If we want to, also sometimes we just use a lowercase letter like V or R or Q or P. Those are commonly used as vectors. And sometimes they're bold. A lot of times in textbooks they'll be bold lowercase letters. Okay, in which so we could name it AB using the starting and ending points, or we could just give it a lowercase letter like that. Sometimes you'll see people put a little arrow above it like that, so you know it's not just a regular variable, but that's a vector. Okay, so the next thing we need to do is write this thing in component form. Okay, so in component form, this vector has an x and a y component. Okay, it's got an x component, which is how far the particle travels in the x direction, and it's got a y component, which is how far the particle travels in the y direction. Let's see if we can take a look and see, right? Kind of like when you figure out the slope of a line, you draw this little right triangle in here. Okay, this is the x component of our vector, right? And this part here is the y component of our vector, and those are going to go here, x and y. This is a lot like the notation for a point in space. A vector is a lot like that, except that you have these pointy brackets on either side of it. Okay, so what is the x value? What's the x component of my vector? Okay, well, it's the distance from this x component to this x component. Well, what's the distance from 2 to 7? That's 5. Yep, it's that easy. You just subtract the x components. Now be careful, don't do 2 minus 7 and get negative 5. This vector is moving in the positive x direction, so it should have a positive x value. Now, will the y value be positive or negative? Well, the y direction is negative. Notice how my vector is moving down. Vertically, it is moving down. So the vertical or y component is going to be negative. Negative what? Well, the difference between 5 and 3 is 2. So this is the component form of our vector AB. Okay? This tells us its direction. It is moving 5 in the positive direction in x, and it's moving negative 2 in the y direction. Okay? So a vector has two things. It has direction and it has, what was that other thing we mentioned? Magnitude. Okay? Direction and magnitude. This tells us what its direction is, but it doesn't tell us what the magnitude is. Okay, so that's what we're going to go to next. This is component form. I'll just write that down. And what is the magnitude? The magnitude of a vector, guys, is just a fancy way of saying the length. It's the length of the vector. And I think that you guys already know how to figure out the length of this thing. Okay, it's a line. How do we figure out how long it is? Oh my goodness, that line is the hypotenuse of a right triangle. How do you suppose we're going to find the length of that thing? You guessed it, we're going to use the Pythagorean theorem. Okay, so here's how we denote the magnitude or the length of a vector. Okay, sometimes it's written like this. If we use this notation, sometimes it's written as this, and sometimes it's like with these absolute value symbols, and sometimes they'll throw in a second bar there. It depends. If you look at your textbook, I think they use just one bar on either side, but if you look online at the Canvas material, I think they use 2 bars. It's the same. Okay, talking about the same thing, the magnitude of the vector. Okay, or maybe if we're using this notation with this little v, you'll see it like that. Maybe with 2 bars. No matter how you see it, it just means what's the length of that vector. Okay, so let's look at our vector here, AB. What's its length? Right? Well, we're literally just finding the length of that hypotenuse. We can just use the Pythagorean theorem. Or, for those of you who remember the distance formula, this thing, x1 minus x2 squared plus y1 minus y2 squared, and you take the x1 and x2 values from our 2 points here from the endpoints of our vector. You could use the distance formula. That's the formula you'll see in your book, and that's the formula that you will see online as well. I like to just think, okay, this thing's literally a right triangle, and I know the x length of this leg, and I know the y length of that leg. I can easily figure out the length of that hypotenuse, right? I've got 2 squared plus 5 squared equals c squared, right? So no matter how I put it, I could just do magnitude, let's write it over here. Magnitude of our vector AB equals 5 squared plus negative 2 squared, square root of all that. The Pythagorean theorem gives us that magnitude of that vector. So it's easy. It's stuff that you guys already know. Square root of, let's see, 25 plus 4, yep, which would be the square root of 29, which I don't think I can simplify. So that right there is the magnitude of that vector. Okay, so in that, what was that? 8 minutes? Geez. We learned about what a vector is, how to write a vector, how to write it in component form, and how to calculate the magnitude or the length of that vector. Okay, next video we'll cover the next topic, which is how to add, subtract vectors and compose them in such a way. Okay, hopefully that helped. Bye now.